Dear students, as we have discussed about the instrumentation of NMR spectroscopy, different type of the NMR spectroscopy such as FAB, SIM, double focusing spectrometry. The efficiency of spectrometry depend upon the resolution of the signals. So today we are going to discuss about the resolution of the compounds. The ability of an instrument to distinguish between the two ions of the equal masses is called the resolution of the instrument. The spectrum consists of a narrow peak. The peak broadening may be due to the distribution of kinetic energy in the beam, change in accelerated voltage, change in magnetic field, and badly collimated ion beam width and space charge of the ion beams. Resolution is expressed as m upon delta m, where m is the equal nominal mass of closely spaced peaks of equal height, one at capital M and the other at the m plus delta m, with the two stipulation that the signal at the valley minimum between the peak must not exceed 10% of the height of the peak maximum. Delta m is the difference in the mass number. Resolution is considered satisfactory if delta m is greater than 1. To distinguish between the mass 200 and 201, a resolution of 1 part of 200 is adequate. Resolution is very effective in the high mass number, and the resolution is a function of the slit width, difference, deflection radius, and homogeneity of the ion source. It is influenced by the pressure in the spectrometer tube. The resolution of an instrument depends upon its application. You can see in the table the resolution of the different mass analyzer. First is double focusing. The mass limit is 1 to 240 and resolution is 10,000 to 2500, and the mass limit is 2 to 5000 and resolution is 10,000 to 20,000. In the single focusing, it is 2 to 700 and resolution is 500, and mass limitation is 1 to 1400 and resolution is 1500. In the quadrupole, it is 2 to 80 mass limit and resolution is 20 to 50, and mass limit is 2 to 100 and resolution is 100. Time of the flight is 0 to 250 and the resolution is 130 and mass limit is 170 and resolution is 150 to 200. For the Fourier transformer, it is 1200 to 2000 and the resolution is 50,000 to 7,60,000. So Fourier transformation is the latest and advanced technique. Resolution is not always uniform over the whole range of mass, which can be detected as shown in the above table. Now we will discuss about the mass spectrum. What is the mass spectrum? What type of the spectrum we will get from the recorder? It is a record of mass and the relative abundance of molecule ions and the positively charged fragments formed from it by electron bombardment. The m upon e ratios are taken along the decision, while the relative abundance are taken along the ordinate. So you have a graph in which you have the relative intensity. The 100% intensity is the base peak or the molecular ion peak, and the other signals of m upon e fragments or the daughter nuclei, which are relatively showing the relative intensity, and the signals at the abscissa upon 1 upon e. So one can have the mass spectrum structure for like this. Thank you.